I'm Konstantin Hohmann. I'm the product manager for precision seeders in the factory located in Soest here in Germany. And I want to give you some details today about our combination of the F-drill fertilizer front hopper and our Optima F with SX high-speed sowing units in the back. We use on this machine F-drill single, as we call it, so an F-drill fertilizer hopper with only one metering unit, one LDOS metering unit with all the features that are well known for the LDOS. And this hopper that you see here is a small one, with the compact one with 1,600 liters. There's also the second execution with 2,200 liters available. You see here there is no front packer assembled, but we also have the possibility to add 3 wheels in there which are steerable to have a nice balancing on the whole machine. I think more interesting is really what we see here in the back of the machine. That's our Optima F frame with SX sowing units. So Optima F is for fold. It's a 6-meter foldable frame which we can equip with either 8 or 12 row units. So we can do row distances of 75, 76.2, 80 centimeters with 8 rows, or with 12 rows 45 or 50 centimeters like we have on this machine here. We have the sowing unit, for example for corn sowing, for bean sowing, for sunflowers, soybeans. In general, we can do everything from rapeseed to sunflower. So we have the seed application in here. You see we have a second single hopper on it, or little hopper on it. This is our micro drill. The micro drill, there we can applicate in parallel also microgranulates, like micro fertilizer as a starter. In some countries also insecticides are popular to applicate them during the seeding operation, or some fungicides are very popular. They are blown into the seeding furrow, so directly in contact to the seeds. As an alternative, we can also put some slug pellets on top as an on-top application. That is the micro. Seed row unit is later, and in front here we have our fertilizer coulter, and with the fertilizer coulter we can applicate some starter fertilizer to give really the crop a major start into life. And this fertilizer coulter is usually located 5 centimeters next to the seeding row, and it should be also 5 centimeters underneath the seeding, so that we have a nice pulling force for the roots to go deeper into the soil, to grow to the water level. I like to open it and explain it. The fertilizer from the front hopper comes always via this hose to the coulter. That is nothing special. Every machine can do that. But now there comes a special thing in action. This is this brush valve, as we call it. So we have this conical brush here, and when the fertilizer is coming, it's at first collected and stored on this brush. And it's stored as long on this brush until this pneumatic valve is opening and shooting it with an air shot through the brush into the furrow. Of course, people asking, how does this valve know when to open or when to close? So to synchronize those two, we use the data of this optoelectronic sensor. So always when the seed is dropping into the furrow, also the valve gets a signal to open the brush, to put a depot in there. We have had different requirements for this Pudama system. The first requirement was we don't want to slow down with the machine. We want to have the same efficiency as before. This valve combination is able to do until 25 shots every second. So working with 25 hearts. This is about 1,500 shots in every minute. So really a lot. But this guides us that we can still operate this machine with, for example, 14 kilometers per hour. In addition, we want to be as gentle as possible with the fertilizer. We want to keep the structure of the fertilizer, not just blowing any dust or meal, flour or whatever into the furrow. And therefore we are really gentle with this brush. We have no mechanical parts that destroy the fertilizer. And mechanical parts is the next topic. We don't have mechanical parts on it, so we don't have any wearing, any friction, any milling on it. So this is really the 3 big advantages that we have here in our system. And by the way, this combination of an air shot and this special brush is patented by Kverneland, so very exclusive, only on Kverneland machines. So what is the main reason for fertilizer? We noticed during some trials that fertilizer is not always 100% available for the plant. There is really an agronomical, or better, a plant reason for it. We have here on a picture a corn plant that is about 3 to 4 weeks old, and you see that the roots are growing only in a triangle of about 10 centimeters width. By typical application of 90,000 seeds, that's typical in this area. Maybe in Africa, I guess it's less. Maybe you're doing 75,000 on a hectare. And 75 centimeters row distance, there is a distance of about 15 or 70,000 seeds, even about 18 centimeters in between two plants. Now we have seen 10 centimeters of roots, but 15 or close to 20 centimeters of distance between two plants. So this means when you have a constant fertilizer application, you're missing some fertilizer in between, which is not available for the plant. And with PUDAMA, we can really concentrate all the fertilizer in a depot underneath each and every plant. And this is a big advantage. And due to our examinations that we did in the first years, we have the thesis that you can save up to 20, or that you can save at least 25% of fertilizer by using PUDAMA. And of course, if a company like Kverneland is doing those trials in Germany, a South African farmer will not trust it or not rely it, so we try to extend it to more countries and with external partners. So we did, of course this is in Europe, but we did in Europe 22 trials with corn and sunflowers with and without PUDAMA, different amounts of fertilizer, and we did this with external stakeholders, so with universities, with fertilizer companies and with seed producers, to have an as objective feedback as possible. Those corn is still growing, so we will present the results on Agritechnica in November on Monday at 10 o'clock on our booth. Next to it, we want to underline that we have three main pillars for PUDAMA. So the first pillar is that we have this agronomical background, really to give the plant a major start, make all the fertilizer that we applicate available. The second pillar is an ecological one. You can imagine if you have fertilizer in field that is not available for the crop, it's washed out. So we have nitrogen or phosphates going to the groundwater, and that's what we don't want to have. Really keep this fertilizer available for the plant, or we keep it at home. And the third reason is really the economic one. And for the farmer, for Mr. Farmer, this is always the most important one. He wants to earn money with this technique. If you imagine that he's saving 25% of fertilizer, and we can do an easy calculation about it. If he usually is bringing 200 kilograms of fertilizer per hectare in the field, and now he's saving 25%, he's saving about 50 kilograms on every hectare. That sounds not that much, but if he's doing, for example, 100 hectares, that will be already 5 tons. If he's doing 200 hectares, it will be 10 tons. And if he's doing 400 hectares, it will be already 20 tons. So 20 tons of fertilizer in a year by a price of 600 euros per ton, what is typical in Germany at the moment, that's already saving 12,000 euros per year, only by this 25% of fertilizer. And with this 12,000 euros of savings, you need about two and a little bit more than 2 years of operation until you have a positive return of invest for this PUDAMA technique, as the PUDAMA technique is also costs some money. But you need a little bit more, that's approximately the calculation between 800 and 1,000 hectares until you have a positive return of invest.
So from my point of view, I'm very excited about PUDAMA. They talked about you have an input cost, but just with the zap of a finger, you know, you get those costs back, and you can just build and be profitable from there going forward. So I think PUDAMA is for me very exciting. Just the quality of the products that they have, I think it's very important for us, and we've got a high standard, you know, from a Jupidex point of view, going into South Africa and Africa as well. We want to make sure we have robust machines, and I think that was shown in the field as well.
But I think really the most important of the machine, as we also say, the heart of the machine, the seed heart, that's our SX sowing unit. The row unit itself, always parallelogram linked to the mainframe, and then you have optionally an hydraulic ballasting, which is really comfortable because you can adjust it on the go from the cabin. This hydraulic ballasting system has also the advantage that it cannot go only pressure to the row unit. With the spring next to it, we can also release some pressure. So in really light conditions that you don't have any bulldozing effect. So this, as it is assembled here, is from minus 30 kilograms, which you can release, up to 120 kilograms, which you can press on the row unit. Then the row unit itself, it's guided by these two gauge wheels. We use open gauge wheels. That has the advantage if there is any dirt on the discs, this is rubbed off by the gauge wheels, it can drop out of the rim, that you don't block your rim from the inside. Those are oscillating and stepless, adjustable for the working depths with this handle. Then we have these two cutting discs, and the cutting discs are opening the furrow for the seats. And in addition, there's always a little coulter in the furrow, which cleans really the bottom of the furrow, that the seeds have the best seed-to-soil contact, that they are not lying on a loose ground, that they are really lying on the tough soil, that they have immediately contact to the soil and immediately access to water. Then we have this catching wheel, which are catching the seeds and pushing them into this nice tight soil. And we have the V-press wheels for closing the furrow, which can be ballasted in 3 steps, and where the angle can be set from collecting the soil onto the furrow or just parallel pressing next to the furrows. But now coming really to the seed heart, the SX seed heart. SX stands for speed and X for geoseed, which is possible with this seed heart. It's a pressurized seed heart. So pressurized means we are not sucking the seeds to the disc, we are pushing them by air pressure to the disc. Then we have this electric driven disc inside with 2 singulators, the first for singulation, the second one for putting all seeds in the same direction. And then we are shooting, also with air support, the seeds through the tube into the furrow. There will be a speed about 70 kilometers, 80 kilometers per hour on the seeds. And during this shoot into the furrow, there is an optical sensor inside. And this optical sensor is not only possible to detect misses, but also doubles. This is really an advantage, because if you didn't set your seed heart in a proper way and you have some doubles, they are also detected, so that you can correct, have the full control in field. So this row unit is able to go to speeds up to 16-18 kilometers per hour if you like, and if the soil, the field is ready for it. But you can also operate it with very low speeds. This is the biggest advantage in comparison to competition, because they can do only quick services, only quick operation. We can also go down. Now I like to show you also the inside of our SX sowing heart. So we open it. We have 2 parts. We have on the one hand the cover. Here comes the airstream. And here come the seeds in, and the seeds are here placed on a level, and then the seeds, this is turning, and by the pressure of the air the seeds are pushed to the disc, and we're always using a stainless steel disc because those are varying slower. And then we have the singulator. The first singulator is really for ensuring that you have always 1 seed per hole, and the second singulator is responsible that all seeds are approximately in the same direction, so that you have a very, very even germination of the seeds. And then down here, and you can see it on the disc, the hole is closed from the back. So there we have an airstream interrupter. So no airstream anymore is pushing the seed to the disc. It's falling off, and at the same time the pressurized air inside is taking the seed, sucking it and shooting it into the furrow. Through the sensor, you see every seed is detected by the sensor, and then it's shooting into the furrow. Our seeders are all equipped with an electric drive, where you have close to no maintenance on it, so you don't have to grease any chains, you have no sprockets that you have to change, nothing. It's really easy to adjust and to maintain. And also in here you have really good access to the seed disc and to the sowing unit, so it's also easy to clean it after the season or when you have to check something during the season. This seed disc that we have here is made for corn. Of course, when you have different crops, always depending on the size of the diameter of the seeds, and on the amount of seeds per hectare, per square meter, we have different discs available. So special discs for rape seeding, for bean seeding, for peas, for peanuts even, for corn, sugar beet, whatever. So we have a wide range of discs available for different operations. Here you see our 60 liters seed hopper. As we have a pressurized system for our seed heart, we have to seal our hopper, and that's the reason why we have this sealing inside here, which seals the hopper 100%. On the one hand, that no pressure is coming out, but on the other hand, of course, also that no dirt is coming in. In the last step, I'd also like to show you how easy it is to exchange the seed disc. Therefore, you just have to block it, and when it's blocked, you can use a standard spanner with 32 millimeters to unmount it, or you can use our special tool. On the seat disc you see we have always this bracket for the spanner. You see the holes. Now it's a 3255, so 32 holes and a 5.5 millimeters diameter. And this is like an agitator disc, that the seats always stay in motion, that they are not blocked inside. Yeah, and here on the seat heart, now you can see really nice this airstream interrupter. And really the special thing, what makes us proud, is that we have very, very low friction, low torque in the seat heart. And the main reason for that is, you've seen there are no ceilings inside, and the seat disc is never touching a ceiling. So this is just in the center, there is a bearing, and that is sealing the complete seat heart. This disc where we mount this bowl where we mount the disc to, is turning absolutely freely, so we have very, very low power consumption and very, very low torque. That is also the reason why our planters don't need any generator on it. So we never use a generator, we just use the power of the tractor. As we are working here with a pressurized precision planting system, we need to get the air from somewhere. And we made a lot of tests, and we want to have as clean air as possible, that we have less dust, less residues in it. And that's the reason why we decided to have this long pipe here. So the air is sucked at the silver part of the pipe, where we notice that there is as less dust as possible, so that the air is as clean as possible.
Yeah, so I think if you look at the technology that's on the market today, I think in Africa, you know, we're only using a little portion of that. So it makes me very, very exciting, you know, of what's coming. Europe is really on the forefront of technology. So we should make use of that in Africa for our African agricultural farmers, especially the commercial guys, and we should use that. And I think, you know, with what's coming now, going forward in the next 4 or 5 years until, you know, 2030 and beyond, that's something that we really should capitalize on.